Hello, this is Miss Edwards, and we are going to do problems 754 to 760 in the review and preview of the CCG geometry book. Problem 754 says use the information given for each diagram below to solve for x. Show all of your work. Question A says line segment BD bisects angle ABC. Remember that means it divides the angle into two equal parts. If the measure of angle ABD is equal to 5x minus 10, and the measure of angle ABC is 65 degrees, we know that ABC divided in 2 equals 5x minus 10. We now just set up an algebraic equation and we can solve for x. The inverse of dividing by 2 is multiplying by 2, so I get 65 is equal to 10x minus 20. The inverse of subtracting 20 is adding 20, so I get 85 is equal to 10x. The inverse of multiplication is division, so x is equal to 8.5 degrees. Looking at question B, it says point M is the midpoint of EF. If EM is 4x minus 2 and MF is 3x plus 9, by the definition of midpoint, we know that those two pieces are equal to each other. So we can set up an algebraic equation to solve for x. To move across the equal sign, you need to use inverse operations. The inverse of positive 3 is negative 3. The inverse of negative 2 is plus 2. So we get x is equal to 11. Be really careful what they're asking you to solve for in these, because sometimes they ask you for the actual length of a segment and you would need to plug your x back in. In question C, it says WXYZ below is a parallelogram. If the measure of angle W is 9x minus 3, and the measure of angle Z is 3x plus 15, solve for x. Well, in a parallelogram, we know that these two angles, these adjacent angles, are equal to 180 degrees. So we have 9x minus 3 plus 3x plus 15 is equal to 180. We want to combine our like terms on the same side of our equation, so we get 12x plus 12 equals 180. The inverse of adding 12 is subtracting 12, so we get 12x is equal to 168. The inverse of multiplication is division, so we get x is equal to 14 degrees. 755, Jamal used a hinged mirror to create a regular polygon like you did in lesson 7.1.4. If his hinge mirror formed a 72-degree angle and the core region in front of the mirror was isosceles, how many sides did his polygon have? Well, if we look at the distance all the way around, we know that that is 360 degrees. So if we divide 360 degrees by 72 degrees, we get that the polygon had 5 sides. Now Jamal has decided to create a regular polygon with 9 sides and call it a nonagon. If his core region is again isosceles, what angle is formed by the mirror. So this time we can take 360 and we can divide it by the number of sides that Jamal decided to create, which will tell us that that isosceles angle is 40 degrees. 7-56. Sandra wants to park her car so she optimizes the distance she has to walk to the art museum and the library. That is, she wants to park so that her total distance directly to each building is the shortest. So if we think back to the previous lesson we did, in order to walk the shortest distance or be the shortest distance, a straight line always creates the shortest distance. So if we reflect the art museum and we rewrite the 50 feet on this side of our diagram, we then can draw a straight line from the library to the art museum. We know that the street is 80 feet long, so if we replace this part of the street with X, we can replace this piece of the street with 80 minus X. We then have two right triangles, so we can set up a ratio. So we can put 60 over X and set that equal to 50 over 80 minus X. We then want to eliminate the denominators. So if we multiply by X on both sides, we get 60 is equal to 50X over 80 minus X. If we multiply both sides by the denominator on the right, we get 1 whole on the right side. And we get 60 times 80 minus X on the left. When we distribute our 60, we get 4,800 minus 60x is equal to 50x. The inverse of subtracting 60x is adding 60x, so we get 4,800 is equal to 110x. If we divide by 110, we get x is equal to 43.64. We then need to see where we need to park, so we need to plug that x value back in. If this side of the street, if we park 43.64, in order to figure out where this point is from the art museum side, we would take 80 minus 43.64, which gives us a distance of 36.36 feet. So the best place to park would be approximately 36.36 feet from the art museum. Write an equation for the following sequences. So sequences, remember back to Algebra 1 and the math notes box previously in this book. When we are given a sequence, they always give us a sequence according to term 1. So they always give us term 1. We have two different types of sequences. We have arithmetic sequences and geometric sequences. So the first thing we need to do is look at how do we go from one term to the next. So in A, to go from 40 to 60 and 60 to 80, I notice that I am adding 20 each time. So if I am adding or subtracting, it is an arithmetic sequence. If it's an arithmetic sequence and we're adding or subtracting, our explicit form of our sequence is in the form y equals mx plus b. For a sequence, we always use the notation a sub n. Our sequence is changing by adding 20 So our rate of change goes next to our variable. And then we need to find our zero term. So the inverse of adding 20 would be subtracting 20, which would tell us the zero term is 20. So we would just put plus 20. To write this as a recursive sequence, if we are given a specific term number, we can say a sub n is equal to 20 times n minus 1 plus 40. When we look at example B, to go from 3 to 3 halves, I noticed that I could multiply by 1/2, or I could divide by 2. In order to go from 3 halves to 3/4, I also can multiply by 1/2. So if you are multiplying to go from one term to the next, it's a geometric sequence. When we write a geometric sequence in explicit form, we also want to use the notation a sub n. We are going to take our zero term, which we need to find. So multiplying by 1/2, the inverse of that to go the other direction would be multiplying by 2. 3 times 2 would give us a zero term of 6. So a sub n equals 6 times our multiplier raised to the nth power. We can also write that as a sub n is equal to 3, using our first term, times 1/2 raised to the n minus 1 power. 7-58, Earl from chapter 6 still hates to wash the dishes and take out the garbage. He found his own weighted coin, one that would randomly land on heads 30% of the time. He will flip a coin once for each chore and will perform the chore if the coin lands on heads. So we're going to work with this probability problem, and we actually in A need to find out what is the probability that Earl will get out. Get out is our key word of doing both chores. So when he flips the coin, there is a 30% chance he will have to do the chore. So if he wants to get out of doing the chores, there is a 70% chance that he will get out using his coin. So we would put 70 over 100 times 70 over 100. We can rewrite that as 0.7 times 0.7, which would tell us there is a 49% chance he will get out of doing both the garbage and the dishes. Question B says, what is the probability that Earl will have to take out the garbage but will not need to wash the dishes? So the probability that he will have to take out the garbage is a 30% chance if he flips the coin, but there is a 70% chance that he will not have to wash the dishes with his coin. So when we multiply 0.3 times 0.7, we get 0.21, which when we change that decimal to a percent, we get 21%. $7.59 says, which pair of triangles below are congruent and or similar? For each part, explain how you know using appropriate triangle congruence or similarity conditions. Note the diagrams are not necessarily drawn to scale. So looking at letter A, we have two triangles, and I am going, because we have the side lengths of both triangles, I am going to set up some ratios. So I'm going to put my 6 over my 2. I'm going to put my 12 over my 4. 6 over 2 simplifies to 3. 12 over 4 also simplifies to 3, and I'm going to put my 15 over my 5, and 15 over 5 also reduces to 3. So we can say that these two triangles are similar by side, side, side similarity. Looking at example B, I noticed that the degrees of my angles of my triangle are listed. So in order to find the missing degrees, I can subtract from 180, and this triangle is missing a 40-degree angle, and this triangle over here is missing a 112-degree angle. So if looking at those two triangles, I can tell that either by angle, side, angle, that these two triangles are congruent. Or I could also tell by angle, angle, side that these two triangles are congruent. Looking at example C, I'm working with two right triangles and I want to find the missing sides, so I'm going to use the Pythagorean theorem. A squared plus 12 squared equals 13 squared. A squared plus 144 equals 169. When I subtract, I get a squared equals 25, and I get my missing side to be 5 meters. On the other side, to find the hypotenuse, I will do 5 squared plus 12 squared equals c squared. 25 plus 144 equals c squared. I have a 169. The inverse of squaring something is square rooting it. And the square root of 169 is equal to 13. So I know by the definition of side, side, side congruence that these two triangles are congruent. Looking at example D, I notice that my top angle in both of my triangles is 62 degrees. I know that my bottom angle in both of my triangle is 48 degrees, which would mean my missing piece in my triangle is both 70 degrees. So I know that by angle-angle similarity, these two triangles are similar. However, when I look at this 12, okay, I notice that the two lengths are not corresponding, meaning they are not the same side. So we can say that these two triangles are similar, but we can absolutely not prove that they are congruent. 760 says part B of problem 759, explain how the triangles are congruent using a sequence of rigid transformations. So if we rotate this right triangle 180 degrees, and then if we translate to match that up, we can see that those are in fact congruent. So rotate 180 degrees and then translate.